Okay. This one left me the most divided, and I'll tell you why as I go throughout it. So in 8.4, acid-base reactions and buffers, the guidelines state explain the relationship among the concentrations in a mixture of weak and strong acids and bases. So I hear the word explain. That usually means words, words, words. So these are sometimes called neutralization reactions. Strong of between strong of each, whichever is in excess, the pH will be in that area. So if you have a strong acid and a strong base together, like strong acid, strong base, if there's equimolar, no limiting reactant, pH is 7. They both got neutralized. If there's more acid than base, the pH will be lower. More base than acid, it's lower. Now, whichever is left over, that is the concentration of the ion that's remaining. So, for example, if there was 1 mole of this and 1.1 moles of this, 1 mole of this would neutralize 1 mole of this, leaving 0.1 moles of hydroxide. 0.1 moles, however, this is calcium hydroxide, so it'd be 0.2 moles of of hydroxide ion. Then you would need to do your calculations to determine pH. So you just see what's left over, what's in excess, essentially. Remember, if you've got a base, you got hydroxide, so you need to do a little bit more to get pH, rather than if you have excess hydrogen ion. Now, different types of situations. You have acid. So weak acid to a strong base, correct? So if there's more weak acid than base, you get what's called a buffer forms. A buffer is a solution that is able to withstand acids or bases being added and changing the pH much. The pH is determined by what's called the Henderson-Hasselbalch equation done later. It comes up in 8.9 towards the end of the unit, so I'll leave it for there. If there's more base than acid, the leftover base moles can be determined because that was the strong base. So you can get the moles of the leftover base and divide it by the total volume. Remember I told you about volume coming into play? That'll give you your concentration of hydroxide. So you got to be a little cautious. The idea is that you got more base, which is a strong base, remember strong. Find out however much moles is left over, divide by the total volume, and that's your concentration. If they're the same molarity, then you'll have a slightly basic pH that can be determined from the equilibrium of this. So keep in mind that if you have equal molarities or equal amounts of these canceling out, you're going to be left with a conjugate base to the acid here and water. So the idea is that these are going to be found through equilibrium, and your pH is going to be slightly basic because there's the conjugate base from the original acid present, while the hydroxide has been neutralized. So that's why it's going to end up on the slightly basic side. Now, when we have bases, a weak base added to a strong acid, very similar. If there's more of the weak than the strong, you need to use Henderson-Hasselbalch, done later. If there's more acid than base, leftover acid moles can be determined. Divide by, again, the total volume to get hydronium, and then pH is pretty straightforward. Same molarity, you're going to end up with a slightly acidic pH based upon this. So again, you'll be doing some calculations with these before, but this is where I come up to where I'm not so sure, because all this is meant to be explained, but if you look at AP classroom videos for 8.4, it's 100% calculations, which I'd suggest you should watch those for those setups. They do a really good job of the calculations, better, but could only do the same. But this is the explanation side. So this may come up as a question for, you have a weak base and a strong acid form, right? They're of equal molarity. What's the acidity going to be? Multiple choice, and it's going to be the slightly acidic one. So like more of those multiple choice questions, but the calculations and maybe a free response, you're going to want to watch this because they're pretty complicated and can get pretty hairy, but they also involve things that we haven't gone through yet, even through AP Classroom. If you have a weak acid, weak base, you get to the equilibrium state by doing this. Okay, so equilibrium, doing the ice, finding out which is which based upon their Ka and Kb values. All right, so come in with your questions. We'll get some practice. But again, these are going to be important based off of the quiz that's there and the ones they're showing. But these kind of concepts you want to have familiar to you as you go through and make, again, more in this unit. All right, talk to you later. Take care.